This video will walk you through your guided notes for how to graph tangent of theta. So at the end of this guided notes, you should know how to graph tangent of f of theta equals tangent of theta. Once again, this theta is just an angle. It's like an x but for angles. And f of theta is like a y. So you should be able to graph y equals tangent of theta. You should also be able to explain the pattern in that graph for tangent of theta. And at the end, you should be able to explain why it is that the graph for tangent of theta has asymptotes. All right. For your notes, most of the notes you can write on this sheet of paper, or you can write on the Google document or on a sheet of paper. But for part of it, you're going to be graphing. And it is much easier to draw a graph on a sheet of paper than it is to try to draw it on the computer. So what I want you to do is grab a sheet of paper, and I want you to create a coordinate plane like this, where the x's go from negative 360 degrees to positive 360 degrees. The y goes from negative 6 to positive 6. Pause the video. Whenever you're ready to continue, hit play. All right, now let's review tangent. So when we were in a right triangle, the way we thought about tangent was that tangent of an angle was equal to the length that was opposite of that angle divided by the length that was adjacent to that angle. But this only worked for angles that were between 0 and 90 degrees. In order to expand it to every other degree, we started thinking about tangent in a unit circle. And in a unit circle, your sine is equal to that opposite side, and your cosine is equal to the adjacent side. Because of this, your tangent of theta was equal to sine divided by cosine. Or that's one way we were able to think of it. Another way of thinking about it is that sine was equal to the y-coordinate of a point going around the unit circle, and your cosine was equal to the x-coordinate of a point going around the unit circle. So if we have a point here going around the unit circle, then your x-coordinate was equal to cosine, your y-coordinate was equal to sine. Okay. I want you to think for a second. So for angles in between negative 360 degrees and positive 360 degrees, when is cosine of that angle equal to 0? If there's more than one answer in between negative 360 and positive 360 degrees, write all the answers here. Pause here, hit play when you're ready to continue. Okay, so because dividing by 0 is not possible, because dividing by 0 would create an undefined answer, I want you to figure out which angle or angles between negative 360 degrees and 360 degrees would make tangent of that angle undefined. If you have more than one possible answer, then write them all here. Pause here, hit play when you're ready to continue. All right. So all these places that you wrote here for number 2 that are undefined, there's an asymptote there. What I want you to do is go to your graph, and everywhere that tangent of theta is undefined, I want you to draw an asymptote. A quick review on how to draw an asymptote. So wherever it's undefined, you're going to be drawing this vertical line like this, a dotted line. And this shows that the graph never can actually touch this particular line. Next thing you're going to want to do is try to figure out, as we're graphing, one of the things you're going to want to figure out is what does the graph look like directly to the left of that asymptote and directly to the right of that asymptote. So for example, is the asymptote as it gets near the graph, as it gets near this asymptote, is it going to head towards positive infinity? As the graph gets near this asymptote, is it going to head towards negative infinity? Or will it do something where it heads towards the asymptote and then there's a hole there where it never actually technically touches it and then continues? And you're going to want to do that for the other side as well. Okay, so once again, but for now, what I want you to do is draw the dotted lines to represent your asymptotes on your graph for everywhere that tangent of theta is undefined. Basically where the angles you got for number 2. Pause here. Hit play when you're ready to continue. Okay, so now here I created tables with a lot of different angles between 0 degrees and 360 degrees. You do not have to fill them all in. What I want you to do is fill in whichever values you think you need to be able to accurately draw the graph of f of theta equals tangent of theta. One hint I will give you is, since we want to find what the graph looks like to the right and to the left of the asymptote, wherever you have your asymptotes here in this table, make sure you're filling in a lot of the angles to the left and to the right of that undefined angle. In order to do this, I would suggest you use a calculator, and I would suggest you write your answers in decimal. So for example, like put in tangent of 0 degrees into your calculator and write whatever the result is right here. Pause here, hit play when you're ready to continue. All right. So now what I want you to do is I want you to plot your points that you wrote here on your graph. So for example, if you had done this point right here, tangent of 0 degrees is equal to 0. So I would plot a point at 0, 0. Do that for all the points that you wrote here on your graph. Pause here, hit play when you're ready to continue. All right, now that you have a bunch of dots here with your asymptotes, I want you to connect the dots to create a smooth curves. Pause here, hit play when you're ready to continue. All right, now you should have now have the graph for tangent of theta from 0 degrees to 360 degrees on the right side here. I want you to use that to help you answer question 3. So looking at your shape, the graph repeats every how many degrees? Once you've answered number 3, I want you to think of your unit circle. And I want you to use your unit circle to help explain why it repeats every blank degrees. Pause here. Hit play when you're ready to continue. Okay. Final thing I want you to do. So you have the right-hand side of this graph filled in. Use that same pattern that you can see to help fill in the left side, to help fill in from negative 360 degrees to 0 degrees.